So a quick update here is I'm taking a detour to build a coil winder, which, you know, it may seem like an unnecessary detour, but I want to get it done and I want it to be something that works the way I want it to. And you know, I'm thinking for each of these machines I'll have like 8 or more coils, and for like the pickup coil ones I might even be using like thinner wire, and it would just be insane, like winding all of those, 723, 724. So anyways, this was like my first thought kind of go at it, and it is alright, but it's a little too flimsy. I mean, nothing's glued in or anything, and you can see I kind of missized that, but no biggie, because I'm realizing this is a little too flimsy and it's a little too small. I mean, I think this would probably end up being a 5-pound coil, and I mean it's just not quite enough. So now I'm transitioning to this, and I thought, there's just no reason in heck to like 3D print the base. So this is just a little bit of basswood, and I did it, as 2-ply. And I've made it bigger, so this is now 8 inches, and this is about 8 inches to here, and this is thicker. And so, this will be set up similar to the other one, and just have a little basswood or balsa wood, support there. One issue that I will find out when I start using this, so I just super glued this here, and in retrospect maybe I should have 3D printed a little screw hole and put a brass screw in to really lock this thing down. My goal here is for it to handle a 5-pound coil well. I don't care about buying 2 5-pound coils versus a 10-pound coil. That's fine. So if the super glue holds for a 5-pound coil, which, I think, I don't know, 90% chance it will, 10% chance it will. We'll find out. But it's not, it's not a showstopper, because if not, I'll just drill a hole in there and screw the darn thing in, and then it's not going anywhere. But this will be much bigger, it'll be sturdier, and then the other issue, which I'll find out as it goes along, is I'll have a little DC motor here, and print something to put in a rubber band going to here. And will the rubber band be too flimsy, and will it just snap if it's like trying to wind a 5-pound coil? And it might be something like, if you were winding a 24 gauge it would be fine, but if you like went to a 14 gauge where you were trying to put some pressure on it, it might not work, or something like that. And I could try and print it as gears and move it up there, but if I can get away with just a rubber band from a little hobby motor, which I think will work, but I'm not sure yet. Then the last part is I've ordered a little magnetic counter, and so there'll be a magnet out here, have the counter, and then the display for the counter out there. And then the very last thing, as I'm thinking about it, I was thinking, I could just run this from a variable DC power supply, and then, you would adjust the speed that way. But I'll probably put a battery into the hobby motor, and then put a potentiometer there, and then that way you can adjust the speed through the pot. I was thinking you could have different sized gears, but it's like, why the hell do that? You could just have a potentiometer and you can fine tune it. You could make 1% changes, whereas if I start like doing gears, there could maybe be like 2 or 3 gears before the rubber band will be like out like that. So last thing is I'm printing the rest of the parts. The coil is running low. I ordered more PLA filament today. It probably won't arrive for like 3-4 days now, and it's 50-50 whether I'm going to be able to print you know, I need to print one more of these, and after this one is finished, it will be 2 more of these, and the rest will just be balsa wood. So I'll let you know what happens when it's finished. Thanks. Last thing I'd say before shutting up today is you may have noticed I've moved the whole coffee table back here. It no longer looks so nice as when I was printing over there, and it has a USB cable attached. So this $220 printer is, shall we say, quirky. And I had trouble with the print, and I couldn't figure out what was going on. And I thought the nozzle was clogged, so I went through this whole, because I'd never done it before, like cleaning the nozzle. And so I cleaned the nozzle successfully, and then I realized that the filament had snapped like right in there, and that was the whole problem. But when I cleaned the nozzle, it kept pestering me to update, and the thing was running fine before, so I never touched the update. And I said, all right, you know, fine, I'll update the software. So I update the software, and the thing just damn well wouldn't run anymore. And I couldn't figure out what it was, and so I said, I'm just going to start from scratch, just, you know, like to the beginning there, as I did at the beginning. And so I plugged it in with the USB port. It runs fine now with the USB port, but once I updated the software, that killed the ability to run wirelessly. So as I said, it's an inexpensive printer, and it has lots of charming quirks. So maybe at some point, if I get all the software and the firmware to match up, it'll print again wirelessly, but I should have left well enough alone. So in any event, it prints again, and as I said, the next part of the video should be the update when I'm testing the coil winder. Stay tuned. Same bat time, same bat channel. Very last thing. The other funny thing was that once I finally got it running again with the USB port, and I went to do a print, the first message that it gave me was, you should now clean the nozzle. You know, it's been, 20 hours. Do you want to clean the nozzle now? I just cleaned the nozzle. So as I said, this thing is, it's a little bare bones, but when you get the thing printing, it's just, it's like, gee, there's stuff that I can do now that I couldn't do before. So, yeah, I'll shut up. So here's a brief update of about where things are now is this. And unfortunately, it says I'm out of filament again. There's still a little left there. They nickel and dime you. And so it's making me, it won't print, even though I just have 3 very small pieces and I have enough to print them, but it refuses to print. So I've ordered more filament, and it'll probably get here maybe Tuesday, and I'm stuck until then. But this you can see is how it's going to look. I realized as I got going that I needed more space here, so this is the only thing holding this piece on, this and a little glue. But it doesn't, it's not doing anything. It's just a shelf. So this is going to be 12 volts. This is actually, I found I had a powerful 12 volt battery lying around. And so this will go to a pot. The pot will go to here. That'll let you adjust the speed however much you want. This is a counter with a little Hall effect. So I'll have a little magnet here, tape the Hall effect there, and that'll give me my counting. And then, maybe anchor that in like that so that I can see it as the thing spins. I think the one thing I'm a little worried is I'll be just spinning this with a rubber band, and whether that'll be enough. I mean, this will be strong enough, I'm 99% certain. But the rubber band, is that going to cut it? Aside from that, it looks fine. The things I need to print a sleeve so that, when this goes on there, it's a snug fit. And, I'll also probably put a little tape so that when this thing turns, this turns. And then I need to print something for the rubber band there and something for the rubber band there. I'll show you something real cool, and then I'll stop. So, the thing is, if you have this thing, then you need to link this to the part that's going to spin. And so, what I probably would have done formally is gone to the toy store and hoped they might have something. But if you look at I'd say that's probably like a 1 millimeter hole there. And again, it might be a little bit of tinkering around. But what I'm saying, this Tinkercad, it's pretty easy and pretty powerful if you care to just take a little time to learn it. So let's make a gear for it. So we'll bring this out here, and I think it's going to be in millimeters. I want it in millimeters. Yeah, it's in millimeters. So we'll make it 10 millimeters. So that's a centimeter. 10 millimeters, 10 millimeters, and 5 millimeters, half a centimeter. Now here's where it's kind of cool. Well, before we get to that, we got to put a hole in the middle of it. So I don't know, maybe a 1 millimeter hole. But these parts will be so small that they won't take long to print. And if they're wrong, it's not going to use much. So now, just go and line it up. Do I have that right? Doesn't look quite right, sorry. No, I had it right. So just line that up and then put the hole in the middle. Now it's got the hole in the middle. But that's not the cool part. Here's the cool part. So we scroll down here to a toroid. We'll drag a toroid out here. It's annoying that thing gets in the way. And make this, I'm just guessing here, 22, because we made the other one 20, 22, and 5 is what the other is, so we'll make this one 5. Yeah. So now we're going to turn this into a hole. And watch this. I might not have it exactly right, but you get the idea, and then you tinker. Let me see if that looks even close. That doesn't look bad. So let's see what that one does. That didn't work. Why didn't it work? It wasn't 22 and 22. I should have it 18 and 18. Sorry about that. So let's try it again. And again, I don't know if this will be exactly right, but it's the idea, and within a few seconds or a minute or two. Oh, come on, what am I doing? Okay, there it is. Now let's see what happens when we make this. Yay! See that? So that's exactly what you'd want. That's what I'd be like mulling around a toy store for. I could even make it a little bit more, than 2 millimeters going in there. And that's the groove for the rubber band. And then what I will do is on the other one, say this one is 10 millimeters. So the other one will be 20 or 30 millimeters, probably 30 millimeters, 3 centimeters. And do the same thing, put the same groove in. And that way you have a 1 to 3 gearing. So you'll have more torque. So the rubber band should have an easier time spinning the thing. And also, I don't know how fast this motor spins, but I would guess, if you turn the pot all the way up, at a minimum, I would guess 1800 RPMs, but it could be like 6,000, I don't know. But if it were 1800 RPMs and you have 1 to 3 gearing, that would be 600 RPMs, that would be 10 revolutions per second. That's pretty darn fast for if you're doing coil winding. So that's why there'll be the pot there, and I'm going to print a little knob for the pot. But you know, it's like, what the heck? I could buy all this stuff, but by the time this thing is done, if it works, it'll be a pretty fancy machine. I mean, it'll be counting everything. I'll have fine control over the speed that I want it to wind. It's just a matter of how well it'll work, but it should work. So that's this part, and then, you know, I need to print that part, which is a small part. I need to print the 30 centimeter, so, you know, about 1 inch other gear, another small part, and then I want to print a little knob for the potentiometer, and that's it, and then it's ready to go. So I'll update this when it's going, and then it's going to be coil winding time. And you know, I really hope this works, because you know, I'd like to use, like, say, some 24 gauge for the pickup coils, and I don't want to be, you know, 1092, 1093. I just want to spin it, and, you know, a couple or a few minutes later it's done. That's how many winds, and kaboom. So again, I'll update later. Thanks. Hey all, so here is the coil winder, and this takes a long time. So screw this. I was gonna put the batteries on there, and that's why I glued this pot in. I couldn't find the solder, and you know, it finally occurred to me, I'm doing this to save time. I've got a variable DC power supply, so let's put that on the back burner. But eventually you could mount this here, run this to the pot, and then use the pot to adjust how fast this is spinning. The main thing so far that I noticed was the gearing. Like, I was originally going to gear it from this, you know, it's just fun printing these little things. Run it from that gear to this gear. It's still way too fast, so I'm just running it right off the axle to this gear here, and that seems to be a good speed. And here's the first coil sitting there. Let me turn it on and see what happens. So this is running at like 6 volts off of, straight from the axle to here, and I should probably pull that in a little bit better. You see, you got the magnet there to the Hall effect, giving you the counter, but that, I mean, that seems pretty fast to me. So the only question left is whether the thing's actually going to spin. I'd say this is about 3-4 pounds of coil, so I'm going to put that here. It's got a little bit of oomph to it, and then it's 12 volts, so I can run it up to 12 volts. So if I can get it spinning at that speed, that'll be great. Okay, I've only got 2 hands, so I'll show you. Ah, it's already off. Oh, one last try, and I'll see if I can do it one-handed, but maybe not. But the wonderful thing is this works. I'm so happy. Oh, it's bent. Just a moment. All right, one more try. Oh, this is going to make things so much easier. Oops, I think I've got enough. No, maybe not. I don't know. I don't care. This coil is not going to be a real one. But that's the idea right there. And in 5 minutes, it would take what would take an hour or 2 to wind by hand, and you're not sitting there 793, 794, 795. So I'm very happy. And the very last thing is, even if I took the rubber band off and I just spun this thing by hand with the magnetic counter, that would still make things easier. But it will work motorized. Yay!